I have hand rubbing sanitizers which are composed of isopropyl alcohol and n-propyl alcohol, the rest being water and some excipients such as the color. Now I am going to extract the isopropanol and n-propanol from these sanitizers. So first of all, I will take a flat bottom flask and into it I will empty the contents. Now to this solution I will be adding a small magnetic bead and then I will add some sodium chloride salt. Addition of sodium chloride will cause the water molecules to bind with the sodium chloride, which will lead to the weakening in hydrogen bonds between alcohol and water molecules. This would help in separation of two layers, the upper layer being alcohol layer and the lower layer being water layer. First I will give it a swirl and then to mix the salt I will keep the flask on a magnetic stirrer. After keeping it at rest for some time, a small layer is formed at the bottom. This is the aqueous layer. So I will first decant off some alcohol in a conical flask and transfer the rest in a separatory funnel. You can see the aqueous layer at the bottom. This was drained off carefully and the upper layer was transferred in the conical flask. To absorb the water, I added anhydrous sodium sulfate. After 24 hours, I checked the moisture with anhydrous cobalt chloride paper and it turned pink, indicating that a lot of moisture is present. I filtered it, but a lot of alcohol was lost in this step. I used way too much sodium sulfate and it didn't even give satisfactory results. To the filtered solution, I added some molecular sieves and shook it and kept it for rest till the next day. The next day, I again checked the water with cobalt chloride paper. Again, it turned pink. I filtered off the molecular sieves because I didn't had more sieves and set the alcohol on a fractional distillation. Cold water is supplied in the condenser. Slowly, the vapor reached the top and the temperature rose to 80 degrees Celsius, which is the boiling point of isopropanol water azeotrope, which consists of 87.7% weight by weight isopropanol. The boiling point of pure isopropanol is 82 degrees Celsius. The temperature remained there for an hour or so, and a lot of distillate was collected at this temperature. When the temperature started rising above 82 degrees Celsius, the receiver flask was changed. The distillate started coming after 88 degrees Celsius, which is the boiling point of n-propanol water azeotrope, which consists of 71.7% weight by weight n-propanol. The temperature kept on rising slowly until it reached 97 degrees Celsius, which is the boiling point of pure n-propanol. When no more distillate was received, the distillation was stopped and some residue of coloring agents, excipients and dissolved sodium sulfate was left inside the boiling flask. I checked both the distillate with cobalt chloride paper. The n-propyl alcohol didn't have a significant effect, but the isopropyl alcohol turned cobalt chloride paper pink. So I measured the density of both the distillates and correlated with the density concentration chart online. The isopropyl alcohol was 91% weight by weight. I checked the volume of both the distillates and it was found that isopropyl alcohol was 66 ml and the n-propyl alcohol was 25 ml. So I added the molecular sieves accordingly to absorb the water. I also added some molecular sieves to the n-propyl alcohol to absorb any water if present and kept it for rest. The next day I filtered it through cotton. The volume of isopropyl alcohol was 56 ml and its density was 0.788 gram per ml, which corresponded to 96% weight by weight. I didn't dry it further and poured it in a glass bottle for storage. Then I filtered the n-propyl alcohol. The volume of n-propyl alcohol was 23 ml and its density could not be calculated as it was less to fill the 25 ml volumetric flask up to the mark. It was also transferred in a glass bottle for storage.
I upload videos every Tuesday, so subscribe to my channel. If you like my work, you can support me financially through Patreon and PayPal. Links are given in description.